We will going to continue our discussion in radiation protection. So today we will discuss first topic will be the basic principles of radiation protection. So take note that the basic principles of radiation protection is different from the three cardinal principles, which we will discuss naman later. So the three basic principles of radiation protection includes justification of practices, optimization of protection, and dose limits for occupational exposure. So for justification of practices, it states that no practice involving exposure to radiation should be adopted unless it produces sufficient benefit to the exposed individual or to the society to offset the radiation detriment it causes. So simply put, when we say justification of practices, before we perform any radiographic procedures, so we need first to ensure that what we're going to perform is justified. Meaning, bago tayo mag-expose sa patient, hanapan muna natin ng request form. So the request form is one of the best ways to ensure na justified yung gagawin nating examinations. We all know that using radiation, using X-rays, can pose harm to our body. Kumbaga, given na siya. But with this, we need to make sure na yung gagawin nating examinations will be justified. Hindi yung sumakit lang yung ulo niya, na-stress lang magpapa-x-ray. So again, hanapan natin ng request form. And the request form means that the patient has already been assessed, evaluated by his or her doctor, and the doctor have already decided na yung specific procedure na yon is the best course of action to assess the patient. So furthermore, under justification of practices, it also states that the net benefit must far outweigh the risks. So ibig sabihin, since again na-mention ko na given na may side effects ng radiation, so i-ensure natin na mas lamang palagi ang benefits. Okay? So the benefits must always outweigh the risk. So ito siya, dapat mas matimbang ang benefit kesa sa risk. Next principle is the optimization of protection or the ALARA. Under that is the ALARA principle. So ALARA stands for as low as reasonably achievable. So according to optimization of practices, we need to keep the doses as low as reasonably achievable, taking into consideration economic and social factors. So when we say as low as reasonably achievable, yung hindi ganon kataas yung ating technique factors, but still it can result to the production of a quality image that is acceptable. Okay? So kasi kung pag masyado namang mataas yung technique factor, if we are aiming for high quality image, so it also entails high patient dose. So kumbaga dun lang tayo sa balance, hindi naman ganun ka high quality ang image, pero at the same time, acceptable ang image and also lower patient dose. Okay, so that is ALARA. So optimization of protection is usually applied at two levels. So the first is the design and construction of equipment and installations. So for putting up an X-ray facility, when we design, when we plan for the X-ray facility and how to install the positions of the equipment, as well as the shielding. So, yung mga bagay na yon, by taking those into considerations, we are definitely considering also the optimization of protection. So, by being able to carefully plan for this, and following the guidelines set by the authorities, by the government, by the agencies. So it also proves that we are aiming for the protection of the patients, ourselves, our colleagues, and the public from the hazards of unnecessary radiation exposure. So another one is the day-to-day radiological practice or the day-to-day radiological procedures. So when we perform examinations to the patients, so we can also optimize the protection by using lead aprons, by using appropriate shieldings, gonadal shieldings, lead gloves, etc. So in that way, we can also optimize the protection. So the ALARA principle, in theory, optimal or maximum image quality allows one to make an accurate diagnosis. Pero yun yung sabi ko, if we want to have an optimal image quality, we need to use high MAS. So pag high MAS, definitely more number of X-rays will be absorbed by the patient, resulting to high patient dose. So, magiging resulta niya, high quality ang image, pero high patient dose din. So, there should be a balance. There should be a compromise between what is optimal and what is acceptable. So, okay na kahit hindi siya ganun kaganda yung ating image, yung quality ng image, pero acceptable siya, meaning nakikita pa rin yung mga structures clearly, yung anatomy and pathology. So, okay na yon. And at the same time, we can also minimize patient dose. Okay, so that is what we mean by ALARA, as low as reasonably achievable. And under ALARA, yung ating three cardinal principles. And these are the distance, time, and shielding, which we will discuss in a while. So, punta muna tayo sa third basic principles. So, it is the dose limits. So, occupational exposure should be controlled so those limits are not exceeded. So, when we say occupational exposures, it means the dose received by the radiation workers, including the rad techs. So, we have to ensure na the set dose limits by the proper authorities should not be exceeded. So, for example, in for Radtex, the dose limits is set at 50 50 millisievert per year. So, kailangan, in 1 year, we should not exceed these dose limits. Okay? So, kumbaga, ito na yung pinaka-maximum na pwede nating receive in a year. Pero dapat hindi siya mag-exceed to ensure na safe pa rin yung ating profession, yung ating work as rad techs. So, to determine these doses received by the staff, by the individuals who are working in the radiation facility like X-ray facility, we are using personnel or personal monitoring devices. So, these personal monitoring devices are used to ensure, to detect, to measure the amount of dose received for a specific period of time. So, these personal monitoring devices will be discussed later. So, ito siya. So, we have here the blue one. So, we have the film badge. Then, we have the packet dosimeters, the TLDs, and the OSL. So, again, we will discuss more on that later. So, ito yung cardinal principles of radiation protection which are under the ALARA principle. So, time, distance, and shielding. So, for time, keep the time exposure to radiation as short as possible. While for distance, maintain a large distance as possible between the source of radiation and the exposed person. And for shielding, insert shielding material between the radiation source and the exposed persons. So for time, so we have to use the shortest time possible, shortest time of exposure. So this means that we need to use shortest time possible. So always minimize time. That is why ang usual na ginagamit natin na time is not in second, not in minutes, but the exposure time is in milliseconds. Mabilis na ang exposure. Kasi pag matagal yung exposure, syempre matagal din na may expose yung patient, it will contribute to higher patient dose. For distance naman, so maintain a large distance between the tube, which is the source of radiation, and the patient, which is who is the exposed person. So when we say large distance, it means that we have to follow the recommended SID. So SID refers to source to image receptor distance, or from the tube up to the cassette or the image receptor. So cassette with film. So the maximum distance should be applied as long as it is within the recommended limit, recommended SID. So the recommended SID for vertical cassette holder for chest radiography is 72 inches. So 72 inches is also equivalent to 6 feet, 180 centimeters, or 1.8 meters. Okay, so maximize natin, pero dapat hindi siya lumagpas sa recommended. Pag tabletop, 40 inches, 100 centimeters, or 1 meter. For shielding, so also we need to maximize the use of shielding. But, take note, we have to ensure na hindi siya makaka-superimpose or makaka-overlap sa ating area of interest. So meaning, we need to maximize the use of shielding as long as it will not overlap or superimpose the area of interest. So again, minimize time, maximize distance, maximize the use of shielding. So ito siya, so time, distance, and shielding. Then, we are done with the basic principles as well as the cardinal principles of radiation protection. So next topic will be the effective dose. So effective dose, this refers to the equivalent dose to the whole body exposure. So usually, this effective dose, hindi siya usually. Effective dose, ginagamit siya when we are talking about the dose received by the radiation workers. So specific siya. Because if we are talking about the dose received by the patient, it is expressed in absorbed dose with a unit of gray or rad. Again, pag patient, so absorbed dose, ang unit is rad or gray. And then pag dose received by the radiation workers, including the rad tech, so we are using the term effective dose or dose effective or dose equivalent or equivalent dose. Pare-pareho lang yan. And the unit is expressed in sievert or rem. So this is the formula for effective dose. So we have the W sub R or the radiation weighting factor times the W sub T or the tissue weighting factor and rad for the radiation absorbed dose. So the tissue weighting factor, so we have also there the table. So for gonads, we have 0.2, active bone marrow, 0.12, and so on. If we're going to total this is equal to 1. Okay? So normally for computation purposes, for whole body exposure, the value of the tissue weighting factor is 1. So ito yung breakdown ng 1. So gonad, 0.2, bone marrow, 0.12, and so on. For the radiation tissue, sorry. For the tissue weighting factor, yung kanina, and then another one is radiation weighting factor. Radiation weighting factor, so every type of radiation is given or is assigned a specific value. So these are the constant values. For alpha, 20. For protons, 2. For neutrons, so depende sa energy. Pag less than 10 keV, 5 ang assigned value. Pag 10 to 100, so 10. Pag greater than 100 keV, up to 20 MeV, that will be 10 also. And for those greater with 20 MeV energy, so 5. For X-rays, gamma rays, and electrons, their assigned value is 1. So we will not compute for this. So I am just presenting you kung paano siya kino-compute, kung saan nanggagaling yung mga values na ginagamit to solve for the dose received by the radiation workers. So this is also, this topic, the effective dose as well as the calculation, is already discussed in your radiation production and characteristics. Another term is MPD, or the maximum permissible dose. So when we say maximum permissible dose, this refers to the maximum dose of radiation that would be expected to produce no significant radiation effects. So meaning, pag sinabi nating MPD, ito yung dose na pwede lang natin ibigay sa isang tao or sa lab tech man, patient man yan, maximum dose na pwede nating i-deliver na hindi makakapag, uh, makaka, ano tawag dito? Hindi makaka-affect. Hindi naman makaka-affect. So, yung maximum distance na, maximum dose na kayang ibigay, i-deliver sa isang individual that will pose no risk. Meaning safe siya, safe dose, maximum safe dose, or maximum permissible dose. So actually, NPD is the old term. Ang new term na ngayon na ginagamit is dose limits. So the weekly MPD for radiation workers or the occupationally exposed persons is 100 millirem. For dose limits, if you're going to use the new term, for dose limits, the weekly dose limits is 1 millisievert. So also take note that MPD as well as the dose limits of the radiation workers is 10 times greater than the general public. So for example, if our dose limit is 50 millisievert per year, so for the general public, it will be 5. So because again, we are 10 times greater. So ang general public natin, they are divided into general public frequent and general public infrequent. So we will discuss more on that later. So MPD again has been replaced by dose limits. So to compute for the MPD, so the formula is 5 times n minus 18, where n is the age of the person. So for example, the maximum permissible dose of a 25-year-old man is about blank at old unit. So we substitute the values. So 25 minus 18 is 7 times 5, 35. So the old value is rem. So that is 35 rem or 0.35 sievert. For dose limits, if you're going to use the dose limits instead of MPD, so this is 10 millisievert times 25 years old. So 10 millisievert times age lang ang formula ng dose limits. So that will be equal to 250 millisievert, which is also the same with 0.25 sievert or 25 rem. So the ICRP in 1991 so recommended a dose limit of 20 millisievert per year. Pero sa ngayon, so since 1991 pa yung 20, ngayon yung ginagamit na is 50 millisievert per year. Pero sa Philippines, so hindi pa tayo nakapag-move on, so 20 pa rin yung dose limits ng mga Filipino radtex. Pero sa ibang bansa, in general, that is 50 millisievert. So ito yung formula ng ating dose limits. So 10 millisievert times 1 age in years.